So let me discuss now about the exponential distribution. It is one of the continuous random variable distribution, or a continuous random variable x is said to have an exponential distribution if it has probability density function given by f of x is equal to lambda e power minus lambda x. That is, we can define f of x is equal to 0 to infinity lambda e power minus lambda x. So as discussed earlier, the continuous distribution is defined from minus to plus infinity, but the exponential distribution is defined only for positive value. So minus infinity is replaced by 0. So the integral will always remain as 0 to infinity until unless the interval is specified. Now the mean of the exponential distribution is given as 1 by lambda. The variance is given by 1 upon lambda square, and the standard deviation is nothing but the square root of the variance, so it is also 1 by lambda. So in an exponential distribution, the mean and the standard deviation are same. Now this is one simple graph of the exponential distribution, where you can see the function f of x is given by lambda e power minus lambda x takes the form of a blue line. Note that lambda is always a positive value. Always a positive value. Now consider an example where it is given as if x is an exponential variate with mean 3, find the probability of x greater than 1. First case. Second case, probability of x less than 3. Now first, all of you should remember the exponential distribution. Note that always f of x is given by 0 to infinity lambda e power minus lambda x, and it's given as mean is equal to 3. Therefore, as I know, mean is equal to 1 by lambda is equal to 3. From this I get lambda is equal to 1 by 3. Now for the first case, px greater than 1, the integral limit could have been taken as 1 to infinity, but with infinity and then integrating becomes complicated. So I take the complement of p of x greater than 1 as 1 minus p of x less than or equal to 1. That's equal to 1 minus integral 0 to 1 f of x dx. That's equal to 1 minus integral 0 to 1, and since lambda is 1 by 3, I'll replace lambda as 1 by 3 e power minus lambda is again 1 by 3 into x. Integrating and then substituting, I get the value as 0.7165. For the second case, p of x less than 3, the limits will take it as 0 to 3 because the maximum value is 3 and the minimum is 0. f of x dx, again replace lambda value as 1 by 3 e power minus lambda by 3 of x. Integrating and substituting, upper and the lower limit, I get the value as 0.6321. Similar example to the earlier case. It's a length of a telephone conversation in a booth which has been an exponential distribution and found on an average to be 5 minutes. So mean is 5 minutes, and the question is find the probability that the call ends in less than 5 minutes, between 5 to 10 minutes. So if lambda is 5, it's given as mean, not lambda. Its mean is 5 minutes. Therefore 1 by lambda is equal to 5. This implies lambda is equal to 1 by 5. Therefore the entire function f of x will take it as 1 by lambda e power minus lambda x as 1 by 5 e power minus x by 5. And for ends less than 5 minutes means it is p of x less than 5. That is, the limits will be from 0 to 5. f of x dx, substituting the f of x function values and the limits, I get the value as 0.6321. The second case ends between 5 and 10 minutes. We will have it as p of 5 less than x less than 10. The lower limit will be 5 and upper limit will be 10. And putting all the f of x values and simplifying, we get the value as 0.2325. One more similar example to the earlier case, where the mean has been given as 3 minutes, and we have to find the probability that the time between two successive arrivals will be 2 minutes or less, that is less than or equal to 2 minutes. So the mean, that is 1 by lambda is 3, lambda is equal to 1 by 3, and using the condition p of x less than or equal to 2. So the limits will be from 0 to 2, and putting the f of x function and integrating and substituting the limits, we get the answer as 0.4866. Now this one question is a very direct question where the lambda itself has been given as 4, and also they have asked what is the probability of waiting less than or equal to 30 seconds, that is 0.5 minutes, that is p of x less than or equal to 0.5. So here, since lambda itself is given, you need not take the reciprocal. So substitute the lambda value as 4 e power minus 4t or x and limits as 0 to 0.5, you get the answer as 0.86.